Welcome to a slow, beginner-friendly lesson on working with directories in Python, made for absolute beginners. The Files and Folders section. In the last lesson you read and wrote a single CSV file by name. In real projects, files live in folders, often many folders. Today you learn to list the files inside a folder, filter them by extension, search recursively through subfolders, and create your own folders. The tool for all of this is pathlib, which you already met earlier in phase 0.6. We take it further now. By the end you can answer questions like, find every .py file in this project, or rename every .csv file in this folder. Beyond a single file, quick recap. Pathlib gives you a path object that represents a file or folder. You import path from pathlib. You create one by calling path with a string, like path_of_contacts.csv. The path object has methods and properties, exists, name, suffix, that plain strings do not have. And it is cross-platform. The same code runs on Mac OS, Linux, and Windows without you worrying about slashes. Today we focus on the methods that list and find files. Path objects, not strings. Files never live alone for long. They gather in folders. Python's pathlib lets you walk those folders like a librarian. Folders hold files. Start simple. Import path. Create a path that points at a folder. Path of dot means the current folder, the one your script is running in. Path of src means a subfolder called src. You can check whether that folder exists by calling the exists method, which returns true or false. Path objects are cheap to create, they are just pointers. Nothing is read from disk until you ask for something, like exists or the file listing. Point at a folder. The simplest way to list a folder is iterdir. It returns every entry inside that folder, files and subfolders alike. You loop over it like any iterable, and each entry is itself a path object. So entry.name gives you just the file name, entry.suffix gives you the extension, and so on. Iterdir does not recurse into subfolders. It lists one level, the direct children of the folder you pointed at. One level, one loop. Here is the shape of almost every directory script. You start with a folder and list its entries. Then you filter, keep only the files, or only a certain extension, or only entries that match a pattern. Then you process the ones that survive the filter, read them, rename them, copy them. List, filter, process. Whether you have 10 files or 10,000, the shape stays the same. List, filter, process. Iterdir returns both files and folders mixed together. To tell them apart, use isFile and isDir. IsFile returns true when the entry is a regular file. IsDir returns true when it is a folder. So you can branch in your loop, print file for files, print folder for subfolders. This matters because you often want to treat them differently, open files to read them, recurse into folders to keep searching. Tell them apart, a very common task, list only files of a certain type. Use the suffix property. For a file named contacts.csv, suffix is .csv. For main.py, suffix is .py. Combine that with isFile and you have a filter, every Python file in this folder. Notice the suffix includes the dot, it is .py, not just py. Comparing against the full .plus extension is the safest habit, because it avoids accidental matches. Pick by extension. Listing files is easy. Picking the right ones, only the CSVs, only the Python files, is where pathlib earns its keep. Keep what you need. Pathlib has a more powerful listing tool called glob. You pass a pattern and it returns every entry that matches. The star matches any characters, so star.py means every file whose name ends with .py. Glob is cleaner than writing your own suffix check, and it handles edge cases for you. Use globstar.csv for every CSV, globstar.json for every JSON, globstar for everything. Patterns do the work. Here are the patterns you will use most. Star.py for every Python file. Star.csv for every CSV file. Data_star for every file whose name starts with data_. And just star alone for every entry in the folder. The star is a wildcard. It stands for any characters. Glob returns only direct children of the folder, just like iterdir. To go deeper into subfolders, you need reglob, which is next. Star means anything. Reglob is glob with an R in front, recursive. It searches the folder and every subfolder beneath it. So path.reglobstar.py finds every Python file anywhere inside the current folder, no matter how deeply nested. This is exactly what you need for questions like, find every .py file in this project. One call, every subfolder, every match. Reglob is one of the most useful tools in pathlib for real codebases. All the way down, path objects give you 4 properties you will use constantly. Name is the full file name, like main.py. Stem is the name without the extension, like main. Suffix is the extension including the dot, like .py. Parent is the containing folder as another path. These four properties let you take a path apart and put it back together without ever touching string slicing. Reach for them whenever you need to inspect or rebuild a file name. Take paths apart. Before you open a file, it is often wise to check whether it exists. The exists method returns true or false. Combine it with an if statement and you can branch gracefully, read the file if it is there, or write sensible defaults if it is not. This is how robust scripts behave. They do not crash on a missing file, they handle it. Exists is cheap to call and saves your users from confusing tracebacks. Check before you act. Make folders, join paths, find files anywhere in a project. Pathlib is how you keep a growing codebase tidy. Shape your workspace. You can also create folders from code. Call mkdir on a path and Python creates that folder on disk. This is how scripts set up their own workspace. Make an output folder, make a logs folder, then write files into them. Mkdir creates exactly one level. If the parent folders do not exist yet, mkdir fails by default. There is a flag to fix that, which we see next. Make a folder. Mkdir takes two flags you will use all the time. Parents equals true tells Python to create any missing parent folders along the way, so output /2026/jan creates all three levels in one call. Exist OK equals true tells Python not to crash if the folder already exists. Together, these two flags let you write setup code that just works whether it is the first run or the 100th. Reach for them whenever you create folders inside a script. Two flags, robust code. Pathlib has a beautiful trick for joining paths. You use the / operator. Base is path of project. Config is base/config/settings.json. The slashes join the parts into one path, and Pathlib uses the right separator for your operating system automatically, / on Mac OS and Linux, / on Windows. You never concatenate path strings with plus again. Use the / operator. It is clearer and it is correct on every platform. / joins paths. Let us put it together. You want every Python file in a project. Import path. Point at the project folder. Call reglob with star.py. Wrap it in list so you can call len on it. Print how many you found, then loop and print each one. 6 lines of code and you have a complete inventory of every Python file in your project, no matter how deeply nested. This is the kind of task that would take forever by hand and seconds with Pathlib. Inventory a project. Here is a slightly bigger task. You have a folder of .text files and you want to rename every one to .md. Loop over globstar.txt. For each file, build the new name with the with suffix method, which returns a new path with the extension replaced. Then call rename with that new path. The file is renamed on disk. Print the old and new names so you can see what happened. 10 files, 100 files, 10,000, same 5 lines of code. This is the power of Pathlib plus a loop. Rename in bulk. Quick self-check. Can you write the line that lists every entry in a folder? Can you filter that listing to only .py files? Can you search through subfolders with reglob? And can you create a folder without crashing if it already exists? If any feels shaky, type it out in IPython against a real folder on your machine. The muscle memory is the lesson. Type it yourself. Here is the lesson in one breath. Iterdir lists the direct children of a folder. Glob filters by pattern, star.py, star.csv. Reglob searches recursively through every subfolder. Suffix, name, and stem take paths apart. Mkdir and the / operator build new paths. Together these tools let you navigate, search, and organize any folder tree. Real scripts rarely touch just one file, they walk folders, and now you can too. Walk any folder tree. Next lesson is the capstone of phase 0.6. You will pull together everything, files, pathlib, and JSON, into one small project. You will read a JSON configuration file, pull values out of it, use those values in code, and write the result to an output file. It is the kind of script you will write again and again in real work. Everything you have learned in this phase comes together there. The capstone comes next. Thanks for learning to work with directories. Next we pull everything together in a config file minilab. The Files and Folders section.